So here's another example of using an area model with a diamond problem to factor a quadratic. First of all, I want you to notice that this quadratic is in standard form. My variables are written in descending powers of x, so I do start with the x squared term, followed by the x term, or the linear term, and then I have a constant here. So because it's in standard form, I can go ahead and proceed. The other thing that's happening here is there's no common factors, right? If I look at the very first term, there's a 5x squared, there's a 19x, and there's a 4. All three of those don't have a set of common factors, right? There would have to be one for all three, and there's not. So I'm going to go ahead and begin by filling in the area model the best I can. I know that this is going to be a 5x squared, and I believe I'm going to write a -4 here. Oops, I don't want these to disappear as I write though. Let me turn off that disappearing ink. So 5x squared and -4. So as we've seen, if these are factorable, the diagonals are equal to each other. So my goal is to kind of build a pair of diagonals that are equal. This particular diagonal, right, is 5x squared times -4, which is a -20x squared. So that's what goes up in the top of my diamond problem. Now that that's there, what I need to do is figure out how many x's are available, and you can see that that's 19. I'm going to write the 19x here. So I create my diamond problem by filling in the diagonal that goes on top, -20x squared, and then the number of x's I have available that goes on the bottom. Basically, we're going to be breaking up these x's into one of two groups. Some of them will be here, and some of them will be here, and then we can finish off factoring this area model. So let's go ahead and see here. I need two numbers that have a product of -19. I'm sorry, a product of -20x squared, and when I add them together, I get a +19. And you know, of all the factors I can use with 20 is 4 times 5, so it's a 2, and a 5. And so it's always good to remember that you could use the 1 also. Basically, that's the prime factorization of -20. One of the two terms is going to have to be negative to produce a -20. And in this case, I'm going to group all of them together except for the 1. So these three will be together. I've got a 20, and right here I've got a 1. And in fact, it's the 1 that needs to be negative. So I'm going to have a -1x, and on the other side, I'm going to have a +20x. Now when I multiply those two, -1x times +20x does give me -20x squared. And when I add them, I get +19x. So those are the two things that I need. I'm going to go ahead and fill those in. I'm going to write a -1x here, and then I'm going to go ahead and write 20x here. So now that I have my areas filled in, I need to figure out what are the items that would multiply to give me those. So I like to start with this bottom row. So I'm going to go ahead, and the greatest common factor for 20x and 5x squared is 5x. So I'm going to go ahead and write a 5x right out here. And if that's a 5x, right, remember how this works. I'm going to multiply something that's going to live here. I'm going to multiply that times this to produce this value right here, to produce 5x squared. So what I need to multiply it by is just by an x. So I'm going to go ahead and put an x right here. I didn't mean that 20 to go away. So this is going to be an x. X times 5x is 5x squared. And if this is a positive x, and I need to get a -1x, this is going to have to be a -1, because -1 times x is a -1x, or -x. If this is -1, this needs to be a +4. And at this point, I'm pretty sure I've got it, because all of my products are in agreement here, right? And you can see that if I multiply the 5x times the 4, I get 20x squared. If I go ahead and multiply the x times 5x, you can see x times 5x is 5x squared. If I multiply the negative 1 times the 4, I do get negative 4. And then the last one that has to work, when I multiply this negative 1 times an x, I have to get a negative x. And that's exactly what I get. So my answer, the factored form of this particular quadratic, would be 5x minus 1 times the quantity of x plus 4.